Hello everyone, my name is Nouman, and in this presentation I'm going to discuss about machine learning. But first of all, I'm very thankful to our teacher Jihad Amra, who give us the opportunity or give me the opportunity to let me represent my presentation. So my topic is on machine learning, and in machine learning the topics that I'm going to discuss are machine learning, supervised learning, unsupervised learning, neural network and artificial neural network ANN, back propagation, deep neural network DNN or deep learning, linear regressions, logistic regressions, and regularization. So let's go to the machine learning. So machine learning, it is a part of AI enabling systems to learn from experience without being explicitly designed and enable them to develop automatically. The learning process begins with observations or data, for example, direct experiences or instructions to find data patterns, and on the basis of the examples we offer to take better judgments in the future. The fundamental objective is to enable the computers to automatically learn and adopt activities without human involvement. So, well, machine learning, once we provide data to the machine learning, the duty of machine learning is to analyze it and learn by itself. And after that, it will use the information or that is analyzed from the given data. It will be used in future. Now here we have supervised learning, and in supervised learning, it is a machine learning activity to learn a feature which transforms an input into an output using input pairs as examples. A supervised steady algorithm analyzes the training data and creates an inferred function to map fresh instances. We have training data in supervised learning. So basically, supervised learning is it analyzes the data, the given data, which is also can be called as the training data. It uses it, and after that it creates a fresh result. Here you can see we have given data into a raw, and the data goes inside the algorithm, which is the supervised learning algorithm, and here's the training data and desired output. So the data goes to the algorithm, and after the processing it separates, or you can say it separated into the subcategories, and here's the output in a good sequence. And here we have unsupervised learning. Unsupervised learning is a machine learning task that draws inferences from datasets consisting of input data without labeled responses. The goal of unsupervised learning is to model the underlying structure or distribution in the data in order to learn more about the data. Clustering and association are some of the unsupervised learning subcategories. So basically, unsupervised learning, it is a learning task that it learns from the datasets consisting of input data without any labeled responses, which means we give them data without any label. So this it carries out the data and with the help of the unsupervised learning algorithm. And here you can see we have given it raw data which has unknown output, no training data set, no label, and it is at the interpretation, and after it goes to the algorithm processing. With the help of the unsupervised learning algorithm, it gives a good output of data. Neural network or artificial neural network ANN. A neural network is a programming model inspired by biology that enables a computer to learn from observational data. The architecture of an artificial neural network is inspired by the human's brain's biological neural network, which leads to a learning process far more powerful than typical machine models. Neural networks, also known as artificial neural networks, comprise of input and output layers as well as a hidden layer of devices that convert information into what may be used by the output layer. They are highly good at activities which need patterns to be found. So this neural network is currently being used in one of the biggest companies for bioengineering, and many companies are trying to work on human brain with the help of neural network to upload data inside the human brain. So it sounds a little bit creepy, but the world has been so advanced that it is now has reached to the level of unbelievability. Now we have propagation, backpropagation. In neural networks, it is a notion that enables neurons in instances when the result does not fit the creator's hopes to change their cached neuronic layer. Well, backpropagation, it is a process that enables neurons with instances when the result that is created does not fit, so it changes it. Deep learning or deep neural network, DNN, or deep learning, it is a subset of master learning in which a large number of layers for the creation of several layers of neural network. It enables a network to extract various characteristics till they can see what they are looking for. So in deep neural network, when the data or the given data is provided in a very large network layer of a neural network, and it fetch or extract the information what it is searching for. Here's the example. As you can see, we have input layer, hidden layer 2, and hidden layer 3. So it analyzes it and these are the layers. It analyzes the layer and it fetches the data which it needs from these hidden layers, and then it provides the output layer. Linear regressions. Linear regressions is a supervised learning machine algorithm. It carries out a mission of return. The prediction value is modeled on a target value based on separate variables. The association between variables and the prediction is basically determined. For example, the prediction of house prices based on historical values is a job that may be employed for linear regression. The root mean squared error RMSE between the forecast y value prediction PRED and the real y value is the cost functions of linear regressions. So the best example I believe for linear regression is an artificial intelligence car. So this algorithm, supervised learning algorithm, is used in artificial intelligence car. It tells when a car needs to stop, or when a car needs to accelerate, or when a car needs to take turn left or right. So here we have the logistic regressions. Logistic regressions is an algorithm used for categorization of machines that is monitored. It is an algorithm for the categorization of observations to a discrete collection of classes. Email spam or not spam, online transactions, fraud or not fraud, are some of examples of categorization difficulties. Logistic regressions changes your output to return the probability value using the logistic sigmoid function. The logistic regressions has two types. One is multi-class type and the other is binary type. So the best example, or which is currently being used in the world, is when we have an email with the spam. You can see the machine or the artificial intelligence behind the email algorithms. It checks that the email that came into us or into the individual is a spamming email. So it analyzes and it finds that the email is a spam email, so it already sent that spam email into the spam box. Same as we have seen in the ATM machine cards. When we use ATM machine card, it accepts, but when we use any card that does not belong to the type of ATM, it rejects it. So logistic regressions, or this algorithm, is used there to observe. Regularization, normalization is a strategy, or regularization is a strategy for changing model of machine learning to prevent the overfitting problem. Regulation may be used to any model of machine learning. Regularization simplifies models which are too complicated and likely to be overfitted by introducing a penalty to the objective function. If a model is overfitted, it will generalize and so make incorrect predictions when fresh data sets are exposed. So when a new data set is sent to check, so there this regularization simplifies that model of data if it is too complicated or likely to be overfitted by the introducing of a penalty of the objective function. And my presentation has end here.